Hey guys, welcome to day one of math, I guess 11, but day one of online math learning. I'm really excited to start this. It's the first time I've had the opportunity to video a lesson and teach it, so I'm really looking forward to it. I've got my computer whiteboard going, I got the camera ready to go, I got my sweatpants on and my purple pen all ready for you guys. And to get started with today. So today we are covering Envision, and this is me practicing a little bit of writing before we get started, but we are doing Envision 10, 8. Oh, it's not so bad. That 8 looks a little sad. But anyway, we're doing Envision 10.8, which is dealing with surface area. And I know you guys did a little bit of surface area content last year. So this should be a little bit of a review, but a little bit of an extension as well, because we're going to go to composite three-dimensional shapes and composite two-dimensional shapes as well. So you guys can get that challenge with it. So we're going to begin today by looking at two-dimensional composite shapes. All right. So we have a city planner who wants all neighborhood parks, and you have a neighborhood park, to have more green space. So we want more green space than non-green space. We want to know, does this park meet the requirements? So we have a park down here. As you guys can see, we have in the top right a rectangle that's a 14 by 12. Okay. We have some road path here as well. Could be a road path or a walk path, I would think. And then we have down here, we have a lot of green space. We have 35 feet going down this way, 12 feet across. Don't know how many feet this is. And then we have a diagonal here. We don't know how many feet that is either. So we want to figure out, does this space have more green space than non-green space? Okay. So looking at it, we're actually going to take our model diagram and create a different model and look at this one. So as you can see, here's anything that's green is our green space, and anything that's non-green is blue. Okay, that's kind of representing our roadway. Take a look how we split it up here. So we have our green space. This was our 14 by 12, so this would be 12 feet right here. Okay. Up here and the rest, so we kind of cut across. So if you look here, we cut across and make a rectangle out of one non-green space, and that's represented by A. If you take a look down here, this long rectangular green space, that comes from cutting all the way. Whoa, that's not a great line there. It's better. All right, cut it coming all the way straight down. So we have our 35 and then our 12 feet, which was here, is now over here. Okay, and you can kind of see how we get this rectangle by cutting straight across, making this into another non-green space. And down here, if you look, when we cut all the way down, just like we did here, we make a nice square. How do we know it's a square? Well, it's a 24 by 24. That would mean that the opposite sides are also 24 feet, making it a square. All sides are the same. Okay, so we have a square here, but we have this cut across that represents non-green and green space. So this diagonal right here is representing those two pieces. We have our 24 by 24. Let's break it down a little bit more. So let's find the area of the non-green space first. Okay, so we've broken it off here. So that, remember, this was 35 feet down and this is 14 feet across. So since this is a rectangle, this is also 14 feet here. So that total length is 49 feet. Same thing going across here. This was 12 feet going across, and this was also 12 feet here. Well, if going from here to here is 24 feet, okay, so that would be 12 more feet to go from here to here. Okay, and this is 12 feet. That total must be 36 feet. But we're going to focus on the rectangle there. So we're going to find the area of our rectangle. So 24 multiplied by 14. When we do that, we get 300 and 36 feet squared. Hey, not so bad. Not so bad. Okay. Then we look at B. Well, we know that this is 11 feet right here, this side of the rectangle. But where do we get 24 from? The 24 comes from down right here, where if you look on the previous one, it told us that this section straight across was 24 feet. That's where that comes from. So we have 24. We want to find the area of that rectangle, 24 by 11. When we do 24 by 11, we get 264 feet. Oh, squared. Got it. Okay. Well, then the last area that is non-green is this triangle down here. Now, if you recall, the formula for finding the area of a triangle is HO is half multiplied by the base multiplied by the height. Well, the half is just a fraction that's there in every finding the area of any triangle. Our base in this case is the 24 feet, which we got from here, from this side of the square, and the height is 24 feet, which we got from this side of the square. Remember, we take half because really the area of any triangle is either half of a square, half of a rectangle, or just half of a rhombus parallelogram. Okay? So we want to take half. We're going to multiply it by 24, which is our base, and multiply it by 24, which is our base. And when we do that, we get 288. Oh, let's see if I can get my 8s. That's, ooh, much better 8 there. Okay, 288 feet squared. Ooh. I've been practicing, and it doesn't show, guys. So, to find the total area of the non-green space, we're then going to add these three areas together. So we have 336 plus 264 plus 288. And when we do that, we get a grand total of 888. And then I ran out of room for my units, so I'll put them right down here. 888 feet squared. And that's just the area of the non-green space. Well, then how do we go about finding the area of the green space? Well, there's multiple ways you could approach this, just like there were multiple ways that you could have broken up this this composite polygon. Now you could go about and finding each area here, just like you did with this part of the composite shape. However, that's more numbers you got to keep track of, more work that you have to keep track of. My recommendation would be take a look at the shape that you have from this composite polygon. You have a rectangle here, so you can just find the area, the total area here of this rectangle, and subtract it by the total area of the non-green space. So when you find the area of the total rectangle, you would take 49. Now how you get 49 is 35 plus 14 that side, multiplied by 36. Oh, that's a big old 3. 36 you get by adding 24 and 12 together. When you do that, you get a total of 1,764 feet squared. So you would take the total area and now subtract it by the partial area, or the area of the non-green space. So you have 1,764 minus 888, which gets you a total of 876 feet squared. Okay. So if you look here, there's 876 feet squared of green space and 888 feet square of non-green space. So this park does not meet the requirement because there's more non-green space than there is green space. Okay, so in this case, the park does not meet the requirement. You could probably make a case like if you added some more, I'll go back a little bit, if you added maybe some more green here, because it's not much area, but just a little bit more green space there, then it would work. Let's move on to our next one. So now we're going to look at a composite three-dimensional shape. Okay, so we have Gavin, who constructed a model building and wants to cover the outside with paper. We know how much paper we'll need to cover the model. This one's going to take a little bit of breaking down to do. So I kind of pre-labeled here. We have 24 centimeters down here, 12 centimeters here, 12 centimeters up, representing this. A total height, sorry, my mouse is jumping around, total height of 20 centimeters from top to bottom, which is represented here, okay, top to bottom, and 10 centimeters on each side. Okay, so we need to find the surface area of this three-dimensional shape. Okay, finding surface area, you just find the area of each shape that you have here, and then add up all the areas. Okay, like I said, we're going to need to break it down little by little here. Well, we know, okay, just by properties of rectangles, that since this is 24, that makes this 24 and this 24 as well. Same thing going this way. It also makes this 24 and these sections 24 as well. The green space is represented by the base, which you cannot see here, this side, and then the reverse back side. Okay. These blue are the top right here of the roof. Okay, that's connecting, that's the flaps on the overlapping it. Okay, so that's saying that since this is 24 down here, you know that this is 24, which then makes this 24 and all the way around. Same thing if you went back this way. That's where we get the 24 from. Now the 12, very similar. Since this is 12 here, this across will be 12. So, and this is just the base. So since this is 12, we're saying that this is 12 as well, and you can't go up any further than that. Okay. Same thing here. Since this is 12, we know that this is 12. Okay. Now here's a little tricky part. Actually, we'll go ahead and start breaking down the rectangles first before we get to the orange colored pieces. So if you look at our rectangles here, we have 3 24 by 12s. Okay, 1, 2, 3 24 by 12s. So since you have that, your 24 by 12s, if you just multiply one of them together, so 24 times 12 is 288. That'd be centimeters squared, and we're going to multiply that by 3 because there's 3 of those rectangles. Okay, I'm going to put a plus sign here. Sorry, guys. So we have those. Now let's take a look at these blue ones. Okay. Now we know that these the sides of the rectangles here are 24 centimeters. But where are we going to get these sides? Well, if you remember, this is the roof part, or the roof. Okay. And when you bring the flap back up, this is going to connect here. Okay. That means this is going to connect here. Since we know that this side length is 10, and it is an equilateral, it is an isosceles triangle, this is going to be 10 here. So that makes this length 10. So we have two 24 by 10s, or 24 times 10 is 200, sorry, I'm going to put it over here, 240. We got two of those, so we'll multiply it by 2. I'll keep adding on. So we've got all of our rectangles covered. Now, let's keep going here with the orange section. Okay. Now, I would recommend, because you're not going to have a formula to find the area of this orange section, is to go ahead and split it into a rectangle and a triangle, where you have 90-degree angles. So you have your a triangle that's up here. Well, how are we going to find the height of this part and this part? Well, that's where this 12 comes in. So if you look, this 12, when folded together, would meet with this edge, making this 12, which means this height is 12. So we know the height of this rectangle is 12, and the base of it is 12, so it actually makes it a square. And we have two of those. So we have 144